Toyota has launched the new BZ5 electric coupe SUV. It uses BYD's Blade battery. It starts at a price of $18,000 US, meaning it is not far off being half the price of a Tesla Model Y.
Every major automaker on the planet spent the last decade telling you they were building the future. They promised electric vehicles that would change everything. Most of them lied and just watched from the sidelines while Tesla and BYD carved up the market like nobody else existed. But in the middle of 2025, one company that everybody had already written off as a dinosaur walked into the most competitive electric vehicle market on Earth and dropped a car so aggressively priced that it shocked every single competitor in the auto industry. The numbers nobody wanted you to see. If you have been following the electric vehicle space, even casually over the last 12 months, you already know that something changed inside Toyota. In the first half of 2026, Toyota's global battery electric vehicle sales surged by more than 135% compared to the same period the previous year. In Europe alone, their BEV numbers roughly doubled. Those are not small gains from a company people kept calling behind the curve. Those are the kinds of numbers that force analysts to rewrite their projections from scratch. And across major markets, including the United States, Europe, and parts of Asia, the total electrified mix across hybrids, plug-in hybrids, and battery electrics now regularly exceeds 50 to 60% of monthly and quarterly sales volumes. Now, before you jump to conclusions and assume Toyota suddenly became an EV powerhouse overnight, let us keep some perspective. Pure battery electric vehicles still represent a small fraction of their enormous global volume. In 2025, Toyota and Lexus together sold approximately 10.54 million vehicles worldwide. Of that staggering total, roughly 199,000 were fully electric, which comes out to about 1.9%. That is not dominance. That is not even close to what Tesla or BYD deliver in pure electric terms. But the trajectory is what matters, and the trajectory has shifted harder than almost anyone predicted. 2 years ago, most industry watchers assumed Toyota would keep dragging its feet on electric vehicles until regulatory pressure forced their hand. Instead, they have quietly ramped production, doubled down on partnerships that would have seemed unthinkable 5 years ago, and started posting growth rates that make their competitors look flat by comparison. What makes this genuinely interesting is the vehicle sitting at the center of this acceleration in one of the most brutal and unforgiving markets on the planet. A car that costs less than $18,000 runs on batteries made by Toyota's biggest commercial rival and was engineered specifically to survive in a market where dozens of new electric models launch every single month, and most of them disappear within a year without anyone noticing they were ever there. You might think a car that cheap from a company that cautious would be a throwaway product designed to grab headlines and nothing more. You would be wrong. And the reason you would be wrong reveals something much larger about where the entire electric vehicle industry is actually heading over the next 3 to 5 years, whether the loudest voices in the room want to admit it or not. $18,000 and a partnership nobody saw coming. The car is the Toyota BZ5, and it rolled off the production line at FAW Toyota's new energy vehicle plant in Tianjin on May 16, 2025. That same day, the facility celebrated its 12 millionth vehicle overall, and the company deliberately tied that manufacturing milestone to the new model's introduction. Formal customer deliveries and a public launch event followed on June 10th, with 4 trim levels entering the Chinese market at prices ranging from 129,800 yuan to 159,800 yuan. At prevailing exchange rates, that starting price converts to roughly $17,999. For a mid-size electric crossover from one of the most recognized and trusted automotive brands in human history, that number is not just competitive. It is almost confrontational. In a market where Tesla's Model Y starts significantly higher, and most domestic Chinese offerings in this size class hover around similar or even higher prices, despite having less established brand heritage and less proven long-term reliability, That number is a direct provocation aimed at every company trying to own the affordable electric vehicle space. But the real story behind the BZ5 is not the price tag itself. The real story is what Toyota chose to do with its pride in order to hit that price point. And the answer tells you everything about how seriously they are taking this fight. The powertrain is a single front-mounted permanent magnet synchronous motor producing 200 kilowatts of peak output and 330 newton-meters of torque. Acceleration from rest to 50 kilometers per hour takes 3.4 seconds, and 0 to 100 comes in around 7 to 7.5 seconds. That motor carries the designation TZ200XS003, and it comes directly from BYD's FinDreams division. The batteries are also BYD's Blade lithium iron phosphate cells offered in two configurations: a 65.28 kilowatt-hour pack rated for 550 kilometers under the Chinese CLTC test cycle, and a larger 73.984 kilowatt-hour pack rated for 630 kilometers. Toyota, the company that spent years publicly questioning whether the world was moving to battery electric vehicles too fast, went to BYD, the company that has arguably done more than any other single manufacturer to prove that the world was not moving fast enough, and said, "Give us your batteries and your motors so we can build a car that undercuts almost everyone in your home market." That is not a corporate partnership born out of polite strategy meetings over tea and PowerPoint slides. That is a survival decision made by engineers and executives who looked at the Chinese market with open eyes and realized they simply could not compete on their own terms at this price point without swallowing some very serious pride. The vehicle itself is a 5-door fastback crossover measuring 4,780 millimeters in length, 1,866 millimeters in width, and 1,510 millimeters in height, riding on a 2,880 millimeter wheelbase. It uses Toyota's dedicated ETNGA battery electric platform, which positions the battery pack low and flat between the axles for structural rigidity, crash protection, and a lowered center of gravity. The claimed drag coefficient is 0.24, which puts it among the more aerodynamically efficient vehicles in its class. Higher trim levels add some genuinely impressive technology for the price. Momenta's 5.0 driving assistance suite combines one LiDAR unit, 5mm wave radars, 12 ultrasonic sensors, and 13 cameras for a total sensor count of 33 elements, backed by 544 TOPS of computing power. The interior centers around a 15.6-inch floating central touchscreen positioned high on the dashboard, paired with a narrow digital instrument cluster, a rotary gear selector, and options including a panoramic glass roof measuring 1.44 square meters. Upper trims bring a 10-speaker JBL audio system, 256 color ambient lighting, acoustic glass, and front seats with a one-touch recline function. 9 airbags, including a front center unit, make up the passive safety package. A FAW, Toyota project manager involved in the program, later described the design brief as delivering Toyota durability standards at a transaction price Chinese households would seriously evaluate. Every sourcing decision, every partnership choice, and every feature inclusion or omission was filtered through that single objective. The question that nobody could confidently answer on launch day was whether Chinese households would actually show up and hand over their money. That answer arrived faster than Toyota probably wanted it to, and it was not the answer they were hoping for. When the market speaks and nobody likes what it says. You can build the most intelligently engineered product in the world, price it lower than anyone expects, and still fail if the market has already decided what it wants. And in 2025, the Chinese electric vehicle market had extremely clear and very specific opinions about what it demanded from a new entrant. Full-year retail registration data for the BZ5 across all of China came in at approximately 10,564 units for 2025. Monthly volumes started at roughly 1,400 in June, climbed through the summer months, and hit a peak of about 3,019 units in September. After that September peak, deliveries declined through the entire fourth quarter. December landed around 1,391 units. By January of 2026, the monthly figure dropped to roughly 500. February was even lower, settling into the low hundreds, and subsequent months through the first half of 2026 have remained stubbornly subdued. Chinese automotive media described the overall trajectory with a word that translates roughly as cooled off, which is the polite industry way of saying the car launched with modest buzz and then failed to build any sustainable momentum. The BZ5 never became a volume hit. It never disrupted the segment in any measurable way. It never triggered a competitive price war or forced rival manufacturers to scramble with matching offers. Now, if you are sitting there thinking that this means the entire BZ5 project was a failure and Toyota wasted its time, you are looking at only one side of a much more complex picture. Because the specific reasons the BZ5 underperformed reveal more about the current state and future direction of the Chinese EV market than any sales chart or market share graph ever could. The BZ5's direct current fast charging peaks near 90 kilowatts, which means a 30 to 80% charge takes about 27 to 29 minutes. That sounds reasonable until you realize that multiple domestic competitors in the same price bracket already offer charging architectures north of 200 kilowatts, and some are pushing toward 400 kilowatt peak rates that cut charging stops to 10 or 15 minutes. In a market where consumers shop on charging speed almost as aggressively as they shop on price, 90 kilowatts feels like it belongs to a generation that has already passed. Chinese consumers in this segment have also grown accustomed to over-the-air software updates that arrive monthly or even bi-weekly, with visible new features, interface improvements, and capability expansions. The BZ5's software update cadence and overall interface polish simply did not match the relentless pace set by brands like NIO, XPeng, Zeekr, and BYD's own expanding lineup of tech-forward models. A regional sales analyst covering joint venture brands offered a candid assessment. The car attracted owners who valued predictable ownership costs and established dealer service networks more than the newest software functions or the fastest charging speeds, but the volume never expanded beyond that narrow and self-selecting segment. The people who bought the BZ5 were not chasing the latest technology. They were buying trust, reliability, and a proven service infrastructure. And in the current Chinese market landscape of 2026, trust alone is simply not enough to move tens of thousands of units per month when your competitors are updating their products faster than most people update their phones. That brutally honest commercial reality is exactly what makes the next part of this story so critical, because Toyota's response to those underwhelming numbers was not panic or retreat. It was patience, backed by a plan that extends far beyond any single model or any single market. What owners actually discovered, after thousands of kilometers, while the sales numbers told one story, the people who actually bought the BZ5 and drove it every day started telling a completely different one. And this story rarely makes headlines because it involves the most boring and most important quality any electric vehicle can have: consistency. Independent Chinese road tests conducted through late 2025 and into early 2026 consistently recorded mixed cycle range achievement between 85 and 90% of the published CLTC figures. Highway runs at sustained speeds of 100 to 120 kilometers per hour typically returned 70 to 87% of the certified distance, depending on ambient temperature, passenger and cargo load, and how aggressively the climate control was running. One Beijing-based driver documented city commuting achievement near 90% of the indicated range under typical 4-ring road stop, and go conditions with the air conditioning running the entire time across multiple weeks of daily use. In a market absolutely flooded with vehicles whose published range numbers bear little resemblance to what you actually experience on real roads with real traffic and real weather, that level of range honesty is genuinely remarkable. A battery systems engineer assigned to the BZ5 program stated during a technical briefing that the priority remained consistent real-world behavior across temperature extremes, rather than maximizing laboratory energy density. That is a fundamentally different engineering philosophy from what most competitors practice, and it showed up most clearly in winter conditions. Northern Chinese owners in provinces where temperatures regularly drop well below freezing reported that the BZ5's thermal management system limited range loss more effectively than several competing lithium iron phosphate vehicles in the same class. Absolute winter figures still reflected the inherent limitations of LFP chemistry, which loses more capacity in cold conditions than nickel-based chemistries. But the gap between the BZ5's summer and winter performance was narrower than most owners expected. Mixed highway journeys exceeding 400 kilometers under rain and variable speeds produced average consumption near 17 kilowatt-hours per 100 kilometers. The official combined figure is 13.5, which means real-world consumption runs roughly 20 to 25% higher than the laboratory number. That gap is actually tighter than many competitors at similar price points, reinforcing the BZ5's emerging reputation as a car that under-promises and over-delivers rather than the other way around. Service experience from the first ownership year highlighted simple maintenance intervals, ready parts availability, and a service infrastructure built on one of the largest and most established dealer networks in all of China. Early owners consistently reported higher residual value expectations than average for the pure electric segment, largely because the Toyota brand continues to carry enormous weight in the Chinese used vehicle market, even as domestic brands gain ground. Foreign automotive journalists who conducted extended drives in China described the vehicle as competent, solidly built and comfortable over long distances, but somewhat restrained in dynamic character and interior software polish compared to the most aggressively updated local rivals at overlapping prices. The running theme was not that the BZ5 was a bad car. Nobody said that. The theme was that it was engineered for a specific type of buyer who prioritizes long-term durability, predictable ownership costs, and peace of mind over technological novelty. And that buyer profile turned out to be a smaller group than the sales projections assumed. That grounded owner experience is valuable on its own, but it also serves as a proving ground for something far more ambitious that Toyota has been working on behind the scenes for years. The battery that could rewrite the rules. If you have spent any time at all following the electric vehicle space, you have heard someone promise that solid-state batteries are about to change everything. You have probably heard that exact promise a dozen times over the last 6 or 7 years. And every single time, the timeline has slipped. The goalposts have moved, and the revolution has been politely postponed to some vague point in the near future. So when Toyota says they are targeting 2027 to 2028 for the first production vehicles equipped with all solid-state batteries, you have every right to respond with deep skepticism. But the difference between Toyota's solid-state program and most of the others that have come and gone is that Toyota is not just issuing press releases and filing patents. They are building physical infrastructure, signing binding supply agreements, and hitting engineering milestones that cannot be faked with a well-designed presentation deck. Idemitsu Kosan, one of Japan's largest energy companies, is constructing a dedicated large-scale pilot facility specifically for production of sulfide solid electrolyte. That facility has a targeted completion date of 2027, and its entire operational purpose is to supply raw material for Toyota's solid-state cell production. This is not a research lab rendering or a concept facility mentioned in a strategy meeting. This is a real plant with real construction crews, real capital expenditure approvals, and a timeline that locks directly into Toyota's stated vehicle introduction window. Sumitomo Metal Mining continues active joint development of high-durability cathode materials under an expanded partnership agreement signed in 2025. Their proprietary powder synthesis methods target one of the most persistent and technically challenging barriers in solid-state battery commercialization, which is cycle life degradation. The cells need to survive thousands of charge and discharge cycles across years of real-world use without losing meaningful capacity. That single problem has killed more solid-state battery programs across more companies than any other technical barrier in the history of battery development. Independent industry analysis published by TrendForce in August of 2026 places Toyota among a small group of global companies that have moved beyond laboratory proof of concept into engineering validation stages. Technology readiness levels for leading Japanese battery suppliers have advanced to TRL 5 through 6, which in practical terms means they have graduated from proving the chemistry works in controlled laboratory conditions to proving it can be manufactured consistently under conditions that resemble real automotive production environments. Sample cells have completed partial performance and reliability testing under vehicle-relevant conditions, including thermal cycling, vibration, and simulated road load profiles. First-generation performance targets remain extremely ambitious. Roughly 1,000 kilometers of driving range under WLO's TP-equivalent test conditions and a 10 to 80% charge time of approximately 10 minutes. Those numbers would represent a generational leap beyond any lithium-ion battery currently in mass production. A later iteration targets an additional 20 to 50% improvement in range beyond that first generation, which would push theoretical range capabilities toward territory that eliminates range anxiety as a meaningful consumer concern. Parallel work continues on next-generation liquid lithium-ion packs intended for 2026 and 2027 model year vehicles. These improved conventional batteries target roughly 1,000 kilometers of WLTP range with better cost structures, improved energy density, and faster charging times around 20 minutes from 10 to 80%. Those batteries serve as the bridge between today's products and the solid-state future, ensuring Toyota has competitive offerings in the market during the transition period. None of this guarantees success. None of it means the technology will arrive on schedule or perform exactly as promised. But it does mean that the gap between laboratory promise and production reality is narrowing in a way that has not happened before in this technology's history, and it is backed by supply chain investments worth hundreds of millions of dollars that would be extraordinarily expensive and publicly embarrassing to abandon. The strategy that nobody finds exciting, but everyone should fear. There is a reason Toyota sold 10.54 million vehicles in 2025, while nearly every other automaker on the planet fought to maintain flat or declining volumes. The reason is hybrids. And the reason nobody in the electric vehicle media wants to spend time discussing hybrids is because hybrids are boring. Hybrids are unsexy. Hybrids are not futuristic. And hybrids absolutely do not generate viral engagement on any platform. But hybrids generate something far more important than clicks and subscriber counts. They generate enormous cash flow. They generate reliability data across billions of cumulative real-world kilometers. They generate deep and lasting customer loyalty in markets where charging infrastructure remains inconsistent, unreliable, or entirely non-existent. And most critically, they generate the financial runway that allows Toyota to invest billions into next-generation solid-state battery technology, pilot manufacturing plants, and global supply chain agreements without betting the entire company's future on a single powertrain architecture that has not yet been proven at scale. A senior powertrain planning executive stated during a technical briefing that hybrids continue to provide the most practical near-term path for markets where charging infrastructure density remains uneven. That was not a defensive comment from a company trying to justify being late to the electric party. That was a mathematically grounded observation about the reality of global automotive markets in 2026. Most of the world does not look like coastal California, downtown Shanghai, or central Oslo. Most of the world looks like rural India, suburban Brazil, regional Australia, developing sub-Saharan Africa, and sprawling Southeast Asian cities, places where a reliable hybrid that delivers exceptional fuel economy and never requires a charging station is not a compromise or a step backward. It is the only practical answer that actually works for the people who live there. New generation hybrid battery technology is scheduled to enter production lines in Japan during 2027, with initial annual capacity planned for several 100,000 units. That technology feeds directly into the same fundamental research pipeline that supports the solid-state program, creating shared knowledge and manufacturing capability that benefits both hybrid and pure electric development simultaneously. The real threat that everyone keeps underestimating. When you look at the BZ5's modest sales numbers and conclude that Toyota's electric vehicle strategy is failing, you are making the same mistake that people made about Toyota's hybrid strategy back in 2003 when the second-generation Prius launched to mixed reviews and lukewarm initial sales. You are confusing a single product's commercial performance in a single market with the strategic trajectory of an entire global organization. The BZ5 was never designed to outsell the Tesla Model Y or dethrone BYD in their home market. It was designed to prove that Toyota could engineer a fully competitive battery electric vehicle at a price point that makes pure electric transportation accessible to a segment of the market that neither Tesla nor most Chinese domestic brands were effectively reaching. And it proved exactly that. The underlying technology works. The real-world range is honest and consistent. The build quality meets long-established Toyota standards. And the partnership with BYD demonstrates that Toyota can source critical components from a direct competitor when the economics demand it, which represents a level of strategic flexibility and organizational humility that most legacy automakers still refuse to consider. In China specifically, Toyota sold more battery electric vehicles than the Volkswagen brand across all of 2025. Approximately 100,000 units compared to roughly 85,000 at the brand level. That comparison deserves serious attention because Volkswagen has invested tens of billions of euros into its electric transformation strategy over the past 5 years, and is still widely perceived as one of the most aggressive legacy automakers in the electric transition. Yet Toyota, the company that supposedly was not trying hard enough, out-delivered them in the world's largest and most competitive electric vehicle market. The BZ5 remains a China-exclusive product, with no officially announced global launch plans. Gray market interest has surfaced in Vietnam, Thailand, and neighboring Southeast Asian markets. But Toyota has deliberately restricted official export channels to avoid undermining pricing structures in regions where they plan to introduce different models tailored to different regulatory and consumer environments. That restraint is strategic and calculated, not a sign of uncertainty. Parallel development continues on improved versions of the global BZ family, including higher capacity battery packs with better energy density, revised power electronics for improved efficiency, and adoption of the North American charging standard port in certain markets. Internal commentary from senior Toyota executives has acknowledged the need to accelerate competitive positioning, with language that translates roughly as a sense of crisis driving faster adaptation across the organization. When solid-state batteries reach production readiness within the 2027 to 2028 window, the vehicle architectures, the manufacturing partnerships, the charging infrastructure agreements, and the real-world customer data accumulated from models like the BZ5 will already be proven and in place. Toyota will not be starting from zero, the way so many critics assume. They will be upgrading a system that has been running, learning, and improving with every vehicle sold and every kilometer driven. A senior product planning executive summarized the company's approach with the kind of understated confidence that Toyota has practiced and refined across decades of global competition, matching the appropriate technology to the conditions of each market at the appropriate time. That sentence does not sound revolutionary. It will never go viral on social media. It will never make anyone's heart race. But if you understand what that philosophy means in the context of a company that has quietly built solid-state pilot plants, secured electrolyte supply chains from dedicated partners, tested thousands of battery cells under automotive conditions, sold over 10 million vehicles in a single calendar year, and maintained profitability through every single major market disruption of the last 30 years, that sentence should make every competitor in the electric vehicle space deeply uncomfortable. Because the company that everyone called slow, outdated, stubborn, and resistant to necessary change just demonstrated that it can build a genuinely credible electric vehicle for less than $18,000 using its biggest rival's own technology, learn honestly from its market performance without flinching or retreating, and simultaneously invest in battery technology that could leapfrog the current generation entirely within 3 years. The question is not whether Toyota can compete in the electric future. The question is whether everyone else can afford to keep underestimating them. Because the last company that made that mistake with Toyota spent the next 20 years watching the Corolla and the Camry dominate their segment while they tried to figure out what went wrong. Drop your honest thoughts in the comments below. Do you think Toyota's patience will pay off? Or have they already waited too long to catch the leaders? Let us know what you think, because this conversation is just getting started.